Namespaces solve a very practical problem. How do many teams, apps, and environments share one Kubernetes cluster without everything blending together? A namespace is a logical scope. It does not create a new cluster. It gives namespaced objects a place where their names are unique. That means dev can have a service called API, and prod can also have a service called API. Same name, different namespace, different object. Namespaces are not nested like folders. Each namespaced Kubernetes object belongs to exactly one namespace. Most objects you touch every day are namespaced. Pods, services, deployments, config maps, and secrets are common examples. But not everything lives inside a namespace. Nodes, persistent volumes, storage classes, and the namespace objects themselves are cluster scoped. Start by listing what exists. The command is kubectl get namespace, or the short form kubectl get ns. A fresh cluster starts with 4 initial namespaces: default, kube system, kube public, and kube node lease. Default exists so you can use a new cluster immediately. In real environments, it is usually better to create explicit namespaces for apps or teams. Kube system is where Kubernetes system components commonly live. Treat it as cluster plumbing, not an application workspace. Kube node lease stores these objects connected to nodes. Those leases help the control plane detect node health without constantly rewriting heavy node objects. Kube public is mostly reserved for cluster usage. The public readable behavior is a convention, so do not treat it as a dumping ground. To create a workspace for an app or environment, run kubectl create namespace dev. Now dev exists as a first-class Kubernetes object. In YAML, metadata.namespace chooses where the object belongs. This service is named API and it belongs in dev. When you run kubectl apply-fservice.yaml, the API server stores the object with both its namespace and its name. Behind the scenes, the identity is not just API. For namespace resources, Kubernetes effectively tracks namespace plus name, such as dev/API. For day-to-day work, the namespace flag is the habit to build. Kubectl get pods-ndev asks only for pods in dev. When you need the bigger picture, use -- all namespaces. That shows namespaced resources across the cluster in one view. If you work mostly in dev, set it on the current context. Then ordinary kubectl commands use dev unless you override them. A classic mistake is thinking an object is missing when your command is simply looking in the wrong namespace. Always check the namespace column or flag. Namespaces also affect service DNS. Inside dev, using just API resolves the local dev service. To reach prod, use the fuller name api.prod.svc.cluster.local. Do not create a namespace for every tiny variation. Use namespaces for teams, environments, or ownership boundaries. Use labels for version, tier, and selection. Namespaces become really useful when you attach controls. A resource quota can limit CPU, memory, storage, or object counts for a namespace. For example, a quota in dev can say, this namespace gets 10 pods and 4 CPU cores. The API server rejects creates that exceed the quota. A network policy can control traffic flow for selected pods. Depending on your network plugin, it can allow only specific namespace or pod traffic. RBAC is the access control layer. A role is namespaced, and the role binding grants that role to users or service accounts inside that namespace. This is the key nuance. A namespace alone is not a complete security boundary. The boundary comes from RBAC, network policy, quotas, admission rules, and cluster configuration. Be careful with deletes. Deleting a namespace is not like closing a folder. Kubernetes will delete the namespace resources inside that namespace. A practical layout might be dev, staging, prod, platform, and observability. Keep it boring, predictable, and easy for humans to navigate. When debugging, ask 4 questions. Which context am I on? Which namespace am I querying? Is this resource namespaced? And are labels filtering my result? The commands to remember are get namespaces, create namespace, get pods-n, set the current context namespace, and list API resources by namespace true or false. So remember this, namespaces give names a scope, teams a cleaner workspace, and controls a place to attach. They organize the cluster, but they do not secure it alone.